While I was performing my studies on Elginvectors, I found that the process where Elginvalues come from aren't actually as difficult as it seems. First, we begin with this expression that states that there's a special vector that does not get rotated, instead it gets stretched or elongated. To simplify it, we need to know that matrix A is acting on vector V, while over here we have lambda, which is the number that we scale the vector by. What I found interesting is that the vector v doesn't change direction despite the scaling of lambda. So we can conclude that the Elgin vector doesn't get knocked off the span like it would with a regular vector if you were applying a linear transformation. Now we rewrite the original expression to introduce the identity of the matrix. We introduce this because on the left side we have matrix times vector, and on the right side we have vector times scalar. And our goal is to have matrix times vector on both sides, not scalar times vector and matrix times vector. Now we subtract the both left and right side to get our answer 0. Now we factor out the vector that was being multiplied by the matrix. And that finishes off with our Elgin value being 0. But then a question arises, why do we have a 0? Why not a non-zero? Because 0 is just useless and boring, it doesn't give us anything. Before we get to that, in total, this tells us that the equation is squishing some non-zero vector into 0. Note that this only works for a singular matrix, not an invertible one. So if we want a non-zero Elgin value, we would need a characteristics equation. Here's an example of how to solve for the characteristics equation. We'll be using this matrix. We set up the identity of the matrix base like this. Notice how the 1s are diagonal to the 0s. That comes into play later on. Now we apply lambda, the number that we are scaling by, diagonally. Then we subtract the matrix we are using from lambda, the number we are scaling by, times the identity of the matrix. And we get 3 minus lambda, 5 minus lambda, and 5 minus lambda. These are going diagonally. Notice how this was the pattern we used when we were doing the identity of the matrix. This is because we subbed in lambda subtracted by the numbers diagonally from the example matrix I gave you guys earlier. And this is the initial format that will lead to unlocking the Elgin value.